This is Brian Murray. I want to welcome you to another episode of Doc Bry, the Physics Guy. Hi everyone, and welcome to this week's blog, which is on the path less travelled, or perhaps the path never travelled. When I was a kid, I didn't really read books. I was a member of the local library, but I never really used it a great deal. I mean, at school, we were forced to read books in English literature, but it was things like Shakespeare's Macbeth, which is completely wasted on 13-year-old boys from Liverpool. The general consensus in the class was that Macbeth was a wimp and that he should stop whining and get a grip. Are these daggers I see before me? What? Man up and go and batter Duncan. That's what we all thought. Anyway, my point is that I wasn't much of a reader, and this continued pretty much until I was about 19 or 20, when I was actually given a book, and it was called A Day in the Life of Ivan Denisovich. And this was a real game changer for me, and it was probably the first book I actually read through choice. I'm not including physics books in this. You don't tend to read physics books. You tend to dip in and out of them. At least I do. You don't tend to read them from beginning to end. Ivan led me to Conrad's Heart of Darkness and Colonel Kurtz, who I met earlier in my life in a film called Apocalypse Now. Now, for those who have never read The Heart of Darkness or seen Apocalypse Now, this is a bit of a spoiler on the way. Kurtz dies, and his final words are, the horror, the horror. And I remember trying to imagine what state of mind he must have been in when he uttered those words. And this really brings me to today's subject, particle physics. When I was a kid, I was taught about electrons and protons and neutrons. Protons and neutrons make up the nucleus of an atom, and electrons go whizzing around the outside. Atoms are really small, but the nucleus is tiny. I remember reading that if the atom was the size of the Albert Hall in London, then the nucleus would be the size of an orange sitting in the middle. I mean, I loved that model. But then Wolfgang Pauli changed everything. And to quote Pauli, "I've done a terrible thing," he said. "I've postulated a particle that cannot be detected." Now, you might be thinking, why is this so terrible? Well, physics is supposed to be able to test ideas. If an idea can't be tested, then chances are it's a stupid idea from a physics point of view. Pauli bet a case of champagne that nobody would ever manage to detect a neutrino. Evidence in the form of beta decay seems to point to the idea that there must be a neutrino out there, and after many years of work we found them on the 14th of June 1956. Now hold on to that idea, because we'll be coming back to it later. So the 20s gave us the idea of antimatter, and the 30s gave us the neutron, the neutrino and the positron, for starters. Theories and ideas started to come out that there may be even more particles, and sure enough they started to appear. Now, I'm not going to bother with the history of particle physics, but suffice to say we now have literally hundreds of particles out there, and the job of trying to figure it out continues to this day. The best model being the quark model, originally dreamed up by Murray Gell-Mann. At least he gets the credit for it, he got the prize. The Standard Model, one of the jewels of modern physics, is based on this quark model. Ignoring electrons for a moment, we have up and down quarks, strange and charm, bottom and top. Quarks also have colour, though this is not real colour as we understand it. At the current time of writing, we have 3 generations of quarks and leptons. We've got some bosons and the infamous Higgs boson. So far, I say, because when CERN gets its 100-kilometre accelerator, which they will, they're going to undoubtedly find a 4th generation of particles. Now, I'm not a big fan of the Standard Model, and if I'm brutally honest, I think it's a load of nonsense. you have to wonder if Murray Gell-Mann and everybody else who started this in this line of work back in the 50s would have seen where it ended up. Would they have looked for another answer? Of course, if the standard model is correct, then there is no other answer. But those in the field know that the standard model falls short and doesn't really work. I mean, for one thing, it doesn't include gravity. I think quarks don't exist, despite all the evidence. I don't think many of the particles that have been found exist, despite all the evidence. Further, I think that this continued chase for more and more particles is hindering physics. We've spent over 40 years looking for dark matter particles at unimaginable cost, and we've yet to find them. We continue to look for more and more exotic particles and develop theories based on these mysterious particles. But what if it's all nonsense? Not just some of it, but all of it. I mean, it wouldn't be the first time in human history, but surely that can't be true. But why not? What happens if Pauli is wrong? What happens if there's no neutrino? What happens if there's no quarks, no muons or tau particles, no lambda, sigma, delta and omega particles, no WIMPs or GIMPs or accelerons or any of the other mystical particles that come out of the imagination of particle physicists? Imagine if 80 years ago we would have taken a different path, one where we didn't need the neutrino or any of the other particles we subsequently discovered. What might this world of physics have looked like? Let's take a walk down that undiscovered path just for a minute. What if we only have electrons, protons and neutrons? What if we only have those three? Now, impossible, you might say. At the very least, we have antimatter. Dirac dreamt it up and Anderson found it. We've seen the cloud chamber photograph, it's there. We have tons of theories and even more data that backs up these ideas. But just for today, let's imagine for one brief moment that we might have it all so very wrong. What if all the particles we see are nothing more than excitations of electrons, protons and neutrons? What if our quarks are nothing more than Gell-Mann's imagination and can be explained away using alternative quantum mechanic models, using the Casimir effect or some other phenomena? What would that mean? Well, for one thing, we'd probably have to bin about 70 years of particle physics. We would have to rethink dark matter, because it would have to be some form of electromagnetic radiation or electrons, positrons and neutrons and nothing else. We'd have to rethink areas of quantum mechanics and so many other things. So many, in fact, that surely it's unimaginable. I've heard that the standard model is described as beautiful, right? Now, I must be looking at a different piece of artwork, because what I see is just plain ugly. So it must be a case of beauty is in the eye of the beholder, eh? But what is the alternative? Imagine if we do away with all those particles and simplify it back to three. Imagine if we looked at another model built only on those three particles plus electromagnetic radiation. What would happen to the standard model? String theory? Well, I think it'd disappear, of course, and we would be constrained to explain all observations using quantum mechanics of three particles and EM radiation. I would think that it would be a considerably simpler solution to the ideas that we've currently got, though it would still require a considerable feat of imagination. Furthermore, the quantum mechanics of this simplified model would ultimately still have to work with general relativity. But again, I can't help thinking that it would be far easier than trying to mesh together an idea that's wrong with one that's right. Pauli used to have a saying, "It's not even wrong," which he used when confronted with an idea he considered incorrect or plain careless thinking. Imagine if ultimately Pauli and his neutrino are not only not right, they're not even wrong. Then surely, when we look back on this period of physics history, we'd find ourselves repeating Kurtz's final words. The horror. The horror. Just imagine. This is Dr. Bry, the physics guy. Hey everyone, this is Dr. Bry, the physics guy. I hope you enjoyed this episode. If you did, can you share it with your friends, your fellow students and anyone you think might be interested? That'd be great and you'd be doing me a massive favour. Subscribe now so that you don't miss out on the latest episodes and news. And check out my website right now at drbry.com. That's drbry.com. And for a limited time, I'm giving away the first part of my 7 ingredients course. It's absolutely free. There's almost 40 minutes of free video explaining the course and why you have what it takes to do physics and how it can change your life forever. And there's also a free download that you can keep. All the details are on my website. I'm also on YouTube, Instagram and Facebook, and all the details are there on drbry.com. drbry.com. I look forward to seeing you soon.